Hello, everyone. I am back for Chapter 2. So let's go through Chapter 2, Psychological Research together. We're going to go through the slides. Once again, you have the option of watching my lecture video, which is essentially what you'll have in class if you were sitting in my classroom. Or you can just go through the PowerPoints on your own. That's up to you. Okay, so this just gives you an option for those of you that would like to listen to me ramble on about how wonderful psychology and psychological research is. All right, so if you have the question, how does television content impact children's behavior? We might want to research that. Might be something important, and it might help us to discover something about behaviors in children, right? So, why is research important? At one time in history, people believed the earth was flat and that mental illnesses were caused by possession. Okay? People can be very wrong in their ideas about the world when they do not rely on evidence to support their claims. Research is a mandatory process in validating claims. So, scientific research is empirical. It is grounded in objective, tangible evidence that can be observed time and time again, regardless of who is observing. Without research, we would only have intuition and groundless assumptions. Okay, so research is what's going to help us validate some of the things that we think may be going on, okay, and hopefully find solutions. Through research, we are able to prove certain ideas through study and testing. Psychology is a science. Okay, so for those of you that say, oh, I don't like science classes, guess what? Psychology is a science, but it's fun science. Okay, we get to enjoy it. All right, so therefore, research is required to not only further investigate something, but provide verification and support the findings. All right, and so right here, you have an image of a skull that has a hole in it. All right, just a little bit of insight. And if you want to dive a little bit further into it, it's a rather interesting story. Okay, so this would be the skull of Phineas Gage, who was working on a railroad and actually had a piece of metal, a long rod, that flew up and projected through his skull and took out a portion of his brain, right? And it changed the way that he behaved and responded to different things, okay? Because a part of his brain was damaged that was instrumental to his behavior, his decision making, all right? So, if you're interested in that story, there's some videos on YouTube on Phineas Gage where you can watch reenactments and those types of things of what happened to him. It's really a neat story, okay? Um, so the use of research information, advertising campaigns often claim to be based on scientific evidence, okay, when in reality it is based off of belief. Okay, so once again, when your parents say, hey, you can't believe everything you hear or see, that's the truth. Okay, so thinking critically about claims. What is the expertise of the person making the claim? Is the person making the claim an actor? What gives them the expertise on a particular vitamin? Okay, might work for them, but it may not work for others. Where's the scientific basis on it? What might they gain if the claim is valid? All right. Does the claim seem justified given the evidence? And what do other researchers think of the claim? Right? So you want to go through and you want to edit all of these things and you want to be smart about them before you make a choice to purchase something, okay, or do something. All right, so the process of scientific research, we have inductive versus deductive reasoning. Deductive reasoning results are predicted based on a general premise. All living things require energy to survive. That's the premise. Ducks are living things, therefore they require energy to survive. That's the conclusion. That's deductive reasoning. Inductive reasoning. Conclusions are drawn from observations. You see many fruit growing on trees, and therefore assume all fruit grows on trees. Not the case. So, number 1, scientists form ideas, theories, hypotheses through deductive reasoning. Number 2, they form a hypothesis, and those are tested through empirical observations, and scientists form conclusions through inductive reasoning. Number 3, these conclusions lead to new theories and hypotheses or more broad generalizations. Okay. Oh boy, the scientific method. If you were not acquainted with the scientific method all throughout middle school and high school, it's going to be a problem. Okay, so familiarize yourself once again with the scientific method because it's used in psychology. All right, scientists use inductive reasoning to form theories which can generate a hypothesis. All right, so much like in a science experiment that you're doing in a classroom, you're coming up with a hypothesis based off of some of those things that you're thinking about. Hey, I wonder if. Okay, it's the same thing through psychology. So a theory is a well-developed set of ideas that propose an explanation for observed phenomena. Hypothesis, tentative and testable statement, a prediction about the relationship between two or more variables. Okay, so the thing you have to remember about a hypothesis is that it has to be testable. It has to be something that you can prove in order for it to become a productive piece of research. Okay, predicts how the world will behave if the theory is correct. Usually an if-then statement. Okay, so if patient is provided this, then this will happen. All right, is falsifiable, capable of being shown to be incorrect. Okay. So let's keep on. And we're going to look back at Freud. Remember, I told you would hear a lot about Sigmund Freud? Here you go. All right. So many of the specifics of Freud's theories, such as his division of the mind into the id, the ego, sorry, my cat's jumping up, and superego have fallen out of favor in recent decades because they weren't falsifiable. All right, so in broader strokes, his views set the stage for much of psychology today, such as the unconscious nature of the majority of psychological. So here we have the conscious, the preconscious, the ego, the superego, the unconscious, and the id. And as we move into consciousness, we'll talk more about that theory. Okay. All right. So approaches to research. Clinical or case studies. Naturalistic observation. Okay. So have you ever just been somewhere and watched how people are behaving just out in public? Are they behaving that way? Are you curious? All right. Surveys. Okay. You've probably seen a lot of surveys. Okay. Did you like this service? Did you not like this service? Archival research, longitudinal and cross-sectional research. Okay. So all of those are going to be different approaches that are going to, we'll talk about as we go through different components of how research works. Okay. So clinical or case studies. Clinical or case studies focus on one individual. The studied individual is typically in an extreme or unique psychological circumstance that differentiates them from the general public. Okay? So it allows for a lot of insight into the case, and it's difficult to generalize results to the larger population because they're unique. All right. So here you have an example of Jeannie. Jeannie was studied by a psychologist after she was found at age 13, having suffered severe abuse and social isolation. Psychologists were interested in the effect of social isolation and what it had on her development. Okay, so we hear stories of people that have been trapped in a basement for years and years and years, and they were isolated. How did that impact them? How did that change them when they came about or suffered some type of abuse? Okay, so those case studies are few and far between. So when psychologists have a chance to study those types of cases, it gives them a unique opportunity to see at how different circumstances impacted and changed a person's behavior and personality. Observation of behavior in its natural setting. Naturalistic behavior is generally hidden under scrutiny or observation. To study the most, so seeing a police car behind you would probably affect your driving behavior. I think we've all been guilty of that. You see a cop car and you immediately start to slow down. Your foot goes off the gas, okay? So that fear of I'm going to be pulled over is changing your behavior, all right? To study the most accurate and genuine behaviors, naturalistic observation has proven most effective. Through naturalistic observations, any feeling of performance or anxiety of the studied individuals is eliminated. Right? You do have to be cautious of bias. Bias runs in everything. Okay, what is bias? An opinion. Okay, so if it has an opinion, it doesn't necessarily mean that it's wrong, but it does mean that you have to be aware of the fact that it could be something that is based on opinion. Okay. So at some point you've likely heard about Jane Goodall. She made a career of conducting naturalistic observations of animals, of chimpanzee behavior, and the modification of work helped her with multiple things in the studies of behaviors, as well as the general population of chimpanzees in a social and environmental setting. Okay. Surveys. A list of questions that can be delivered in many ways, on paper, pencil, electronically, verbally. You'll be asked to do a survey on me at the end of the course. Okay, so you're very likely used to surveys. All right, surveys can be used to gather a large amount of data from a sample, a subset of individuals, from a larger population. Surveys can be administered in a number of ways, including electronically administered research, like the survey shown here. Okay, so here you have an example of that. Archival research uses past records or data sets to answer various research questions or to search for interesting patterns or relationships. Okay, so looking at what's been done in the past, how does that impact the research that I am using and doing now? Okay. All right, longitudinal and cross-sectional studies. These are very interesting as well. So cross-sectional research compares multiple segments of a population at a single time. Okay, so such as different age groups. Okay, what if you're putting in particular age groups, how are they reacting to different situations at the same time? Okay, longitudinal studies are studies in which the same group of individuals is surveyed or measured repeatedly over an extended period of time. A lot of times this comes down to like twin studies and things like that. They want to see how those twins react to one another and environmental stimuli from birth through whatever age. Okay, so it may be that they start out at birth and they may follow them all into adulthood just to see how different things impact them. So longitudinal has the word long in it. So remember that's going to be a long study over a particular or same group of small individuals. Okay. Researchers often expect some participants to drop out, particularly in this type of study, and therefore often initially recruit a lot of participants. Okay, at some point the twins may say, hey, y'all started with this when I was a baby and had no idea what was going on. I don't want to continue on with this. I don't want somebody following my life. So they make sure that they have people multiple studies going at once on these longitudinal studies so they don't lose all that data that they've gone through. Attrition is the reduction in number of research participants as some drop out of that study over time. So just make sure you're making note of some of these vocabulary words. All right. All right, correlational research. Okay, so this is a scatter plot. We have correlation If you were to go into upper level psychology classes, you would be taking psychology statistics, and that's where you would get a deeper understanding of some of these different things. But I want you to go ahead and have some foundational pieces to it. All right, so correlational research. Correlation, relationship between two or more variables. When two variables are correlated, one variable changes as the other does. Okay. Correlation coefficient, the number from a -1 to a +1, indicating the strength and direction of the relationship between variables, and usually represented by R. Causative correlation, two variables change in the same direction, both becoming larger or smaller. Negative correlation, you have two variables change in different directions, with one becoming larger as the other becomes smaller. A negative correlation is not the same thing as no correlation, right? So here you can kind of get an idea of what these scatter plots would look like if you were documenting data between variables and whether they had a correlation or not. Okay. All right. Correlation does not indicate causation. Say that to yourself multiple times because you will see it again. You will hear it again. And it's something you want to make sure you have in your mind. It makes sense when you think about it. Okay. So once you process these terms and get them down, you'll see where it will make a relationship with you in different things that you're going through every day. Cause and effect relationship. Changes in one variable cause the changes in the other variable. Can be determined only through an experimental research design. Okay, so cause and effect. Because I do something, the effect is what happens. All right. Confounding variable. Unanticipated outside factor that affects both variables of interest, often giving the false impression that changes in one variable causes changes in the other. So here's some examples for you. As ice cream sales increase, so does the overall rate in crime. A relationship exists between ice cream and crime, but is it correlational or does one cause the other? Okay, so think about it. In this example, temperature is a confounding variable. As the temperature increases, ice cream sales increase. And so then therefore, it might be less likely to have to be outside, increasing crime rates. Okay, so think about those things and how they work. Okay, but just remember, correlation does not indicate causation. Okay, all right. Does eating cereal really cause someone to be a healthy weight? Something to think about. All right, illusionary correlations. As well as mistaking correlation for causation, people can also make false correlations. Okay, if that's not confusing you, then great. If it is confusing you, just wait. Maybe it'll all start to make sense for you. Illusionary correlations, seeing the relationships between two things when in reality, no such relationship exists. Okay, takes us back maybe to the ice cream and the crime, maybe. Confirmation bias, tendency to ignore evidence that disproves ideas or beliefs. Okay. Once again, it has that word bias in there. Okay. So keep that in mind. Illusory correlations can be involved in the formation of prejudicial Attitudes that can lead to discriminatory behavior. Many people believe that a full moon makes people behave oddly. Research demonstrates that this relationship does not exist. Okay, so when you hear a teacher say, "Oh, it must have been a full moon last night," just know that it really had nothing to do with the way the children were behaving. They were just acting crazy because they did. Okay. All right. Causality, conducting experiments and using the data. The only way to establish that there is a cause and effect relationship between two variables is to conduct a scientific experiment. A scientific experiment has precise requirements for design and implementation. The experimental hypothesis. Hypotheses can be formulated through observation. Oh, well, I wonder if this happens, if it will cause this. Okay. And after review of previous research. Maybe you read something and you say, hey, I wonder if they thought to look a little bit further into this. Okay. You might be the person to do that. Right? Designing an experiment, you have experimental and control groups. An experimental group is the participants that experience the manipulated variable. Okay. This is the group designed to answer the research question. The control group, participants that do not experience the manipulated variable, serve as a basis for comparison and controls for chance factors that might influence the results of the study. Experimental manipulation is the only difference between the experimental and control groups. So any differences between the two are due to experimental manipulation rather than chance. Okay. Defining variables and how they will be measured. We have an operational definition, a description of what actions and operations will be used to measure the dependent variables and manipulate the independent variables. Okay, and we'll look at some researches. I will do my best to kind of get some together for you so you can kind of see what these would look like from an instructional end, okay, if you were the presenter of this research. Avoiding bias and the placebo effect. You may or may not have heard the term placebo before, but let's go through that just so that everyone is aware. Okay, so experimenter bias. The researcher's expectations skew the results of the study. Okay, so remember I told you that bias, that opinionated part, can really have a negative impact on the research. Participant bias, same thing. Participant expectations skew the results of the study. Okay. There are two different kinds of studies here that are identified. You have a single blind study, an experiment in which the researcher knows which participants are in the experimental group and which are in the control group, but participants do not. Okay. Then a double-blind study, an experiment in which both the researchers and the participants are blind to group assignments. Okay. All right, so let's dive into the placebo effect here. People's expectations or beliefs influencing or determining their experience in a given situation. When people are given a pill to improve their mood may increase just because they believe it will. To know if a medication is really having an effect or whether it is a placebo effect, the experimental group receives the medication and the control group receive a placebo treatment, which would be just like a sugar pill. Okay, it has no form of medication in it. This is a double-blind study. Any differences between the groups will be due to the medication. Okay, so finding out if the medication truly works or if it's just all in their mind. Okay. All right, so providing the control group with a placebo treatment protects against biases caused by expectancy. Okay. Variables. We have an independent variable, which is a variable that is influenced or controlled by the experimenter. Ideally, this should be the only important difference between the experimental and control group. The dependent variable is a variable that the researcher measures to see how much effect the independent variable had. Okay. All right, selecting participants. All right, so I've said repeatedly, I taught a high school psychology class. I actually had 2 of them going at once. And so they were participants a lot of times just to kind of see how the research part of it worked. So participants are subjects of psychological research. Populations are too large for a researcher to include everyone, so samples are used. Okay, so they're identifying certain people within that. A sample is a subset of individuals selected from the larger population. The population is the overall group of individuals that the researcher is interested in, for example, college students. And the random sample is the subset of a larger population in which every member of the population has an equal chance of being selected. This form of sampling is preferred because it is more likely that the selected participants will be representative of the larger population based on sex, ethnicity, social economic status, etc. Okay, so meaning you're getting a broader realm of what you're looking for. Assigning participants to groups, whether it be experimental or control. Random assignment, the method of experimental group assignment in which all participants have an equal chance of being assigned to either group. This can be achieved using statistical software or by simply flipping a coin, heads or tails. Okay. Prevent systematic differences between groups such as gender and age. Without random assignment, an experiment cannot find a true cause and effect relationship. Any relationship could be due to pre-existing differences between the groups. Okay, so age, race, sex, those types of things. Random assignment helps to avoid pre-existing systematic differences so that any significant differences between groups can be said to be the result of the manipulation. Okay. Issues to consider. So manipulating variables. As stated, random assignment is required to state causation. Once randomly assigned, each group is then manipulated in some way. However, some experimental designs are more complicated. So here we have an example, the effect of sex, male, female, on spatial memory. So sex is your independent variable. It cannot be manipulated. Okay. Males and females cannot be randomly assigned. This kind of an experiment is therefore called quasi-experimental. A cause and effect relationship cannot be determined from this type of experiment. Okay, so let's move into the ethics. This has changed. Some of the studies that you will see moving forward, you'll see you'll see a prison study. You'll see a couple of different ones where ethics were not a fundamental part of the research ahead of time. It wasn't until they had the research that they realized that it may have a bigger impact on the participants than they thought. So ethics came into play. Some questions cannot be answered using an experimental design because they would be unethical. Okay, so here you have a couple of examples. Make sure you're reading through those. Make sure that you're kind of familiarizing yourself with ethics. Now, in order to have research studies done, if you're doing a research study, a research experiment, you have to be able to talk or explain the generalizations of what you're doing and what the expectations are. You also have to give the participants a debriefing, kind of go through everything at the end, and then give them opportunities to follow up on. Okay, so you have to take care of those participants because they're there to help you with your research. You don't want to have a long-lasting impact that impacts them for the rest of their lives because of it. So interpreting experimental findings. Once data has been collected, a statistical analysis is conducted. A statistical analysis determines how likely any difference between experimental groups is due to chance. Psychologists usually discuss results as a significant or non-significant. If the odds that the difference occurs by chance are 5% or less, then the results are significant. Okay. A true experiment includes including random assignment, manipulation of the independent variable, and control of extra variables reduce the odds of results occurring by chance. Okay. So rather than y'all hear me tongue twist on that one, I shortened it for you. Okay, so report findings. Research is usually reported in scientific journals, usually aimed at an audience of professionals and scholars. Articles published are peer-reviewed journal articles. Okay, so let's look at this because you're going to be responsible for making sure that you find some peer-reviewed journal articles for your research that you will do for your research paper in this course. So peer-reviewed journal articles are articles read by several other scientists, usually anonymously, with expertise in that subject matter, who provide feedback regarding the quality of the manuscript before it is accepted for publication. Okay, so generally when you see a peer-reviewed article somewhere, then you know it's gone through all of those components before it was published. It helps to weed out poorly conceived or executed studies, improves articles with suggested revisions, determines whether the research is described clearly enough to be replicated by other researchers. And this, again, is an important piece. When you see that term replicated, okay, if you are performing research, you want to make sure that another researcher can come in and perform the same type of research with the same result. Okay, so replication determines the reliability of the original research design, showing that it is something that we can believe in. Okay, can include additional measures that expand on the original. Okay, so they want to go a little bit further into it, dig a little further into it to see if there's extra pieces that can be added on. That might be something they can do. Provide more evidence to support the original finding. Okay, so something that they're doing in addition to something that has already been established. Okay, so that replication is very important. Bad science and retraction, the vaccine autism myth. Okay, so this is political, of course. You agree or you disagree, that's fine. Okay. Many peer-reviewed publications published research making claims that routine childhood vaccinations cause some children to develop autism. Okay. Since these reports, large-scale research was carried out suggesting that vaccinations are not responsible for causing autism. Many of the original studies have since been retracted. It was found that leading research in the original study had a financial interest in establishing a link between childhood vaccines and autism. Unfortunately, the initial claims were publicized and many people still think vaccinations cause autism. Okay, once again, like I said, completely political here. People are going to have their views. You might be one of the ones that still believes this, and that's okay. All right, I'm not here to judge you. I'm just here to give you the information. Okay. Reliability and validity. Reliability is consistency and reproducibility of a given result. Would the same test give the same results every time? Do the instruments, tools used to collect data do so in consistent, reproducible ways? Okay. When a study involves observations by multiple people, it is important that they all make observations and record them in the same way. Right? So if you're going based off of another study, it needs to be done the same way in order for it to replicate properly. Inter-rater reliability is a measure of agreement among observers on how they record and classify a particular event. A reliable, consistent measurement does not always mean that it is measuring something correctly. Validity. The accuracy of a given result in measuring what is designed to measure. Does a test measure what it's meant to measure? Okay, so just keep that in mind. All right, you want to make sure that something is reliable, a study is reliable and valid. Okay. Once again, here's the ethics, and it talks a little bit about the informed consent that I mentioned earlier. So research involving human participants must adhere to strict guidelines. You can't just say, okay, I'm going to go out and do this research and not have informed consent. Okay, you have to, by law, have informed consent now. Okay, the Institutional Review Board is a committee of administrators, scientists, and community members that reviews proposals for research involving human participants. Exist at any research institution that receives federal support for research involving human participants. Okay. Generally, IRB must approve a research proposal before it can be processed or go forward, proceed. So what does informed consent look like? This is something that you would have to state or have a written document for those participants. Process of informing a research participant about what to expect during an experiment, and then obtaining the person's consent to participate. Now, once again, like I said, they can't give you all the details of the research because that might impact the research, okay? But they do have to give some of the important details, allowing you to know that there are some risks there, okay? So, one, potential risks involved, implications of the research, notification that participation is voluntary, meaning you can leave at any time, notification that any data collected will be kept confidential. Okay. All right, so deception. Sometimes deception is necessary to prevent the participants' knowledge of the research question affecting the results as long as it is not considered harmful. Okay. So deception, purposely misleading experiment participants in order to maintain the integrity of the experiment. Remember I told you that sometimes they can't give you all the details because it would impact the experiment that they're trying to perform. Debriefing. When an experiment involves deception, participants are told complete and truthful information about the experiment at its conclusion. Okay? So before that person can leave wherever they're at participating in this study, they have to be debriefed. Okay, this is what we did and this is why. Okay, because they don't want people walking out of there with some major change that's going to impact them for the rest of their lives. The Tuskegee syphilis study. All right, so ethical guidelines have not always existed. And this is one of those. I mentioned the prison experiment. That was before all of this started to take place as well. But this one, in this one, the ethical guidelines have not always existed. In 1932, participants were recruited in an experiment studying syphilis in black men. Participants that tested positive were not informed that they had the disease. Although no cure existed at the beginning of the study, a cure was found in 1947, which was penicillin, but it was not administered to participants. Many participants unwillingly spread the disease and many died. Okay, so think about the implications of that. Had those men known, hey, you have syphilis, then they would have been able to go back and receive help, okay, because they would have known their condition and they wouldn't have likely spread their condition, okay? But because they were not debriefed at the end and told that they had tested positive for syphilis, it impacted them in the end, okay, leading to the spread and death of those gentlemen. All right, research involving animal subjects. We hear this time and time again. 90% of psychological research involving animal subjects uses rodents or birds. And like I told you, in my undergrad studies, we used rats. Animals make good substitutes because many of their basic processes are sufficiently similar to those in humans. Animals are used when the research would be unethical in human participants. Research must still aim to minimize pain or distress. Okay. The Institutional Animal Care and Use Committee. This committee of administrators, scientists, veterinarians, and community members that reviews proposals for research involving non-human animals. Okay, so there are some steps to start changing things. Okay.